The fundamental counting principle says, if you have an event which is a combination of other events, like what? The very first event can be done in n ways. The second event can be done in n ways. In total, the event can be done in m times n ways. And remember, you can generalize this principle as well. You can generalize this rule as well. That's the important part. What's the meaning of that? It means that if the first event can be done in m sub 1 ways, the second event can be done in m sub 2 ways. The third event can be done in m sub 3 ways, and you continue this process. How many events you have? N events. The last event can be done in m sub n ways. Then the whole event, the whole experiment, then the event can be done in m1 times m2 times m3 times m sub n ways. So that's how we can generalize this idea. One important example was the following. Suppose you want to choose a PIN code for your car. Example. A PIN code for a car can consist of two digits. You want to answer the following question. How many pins are possible if you can repeat the digits? And the second part of the question says, how many pins are possible if you cannot repeat any digits? So I'm going to erase this part of the board so I can have more space and explain this to you. So you have a PIN code which consists of two digits. So basically the first digit and the second digit. This is your first digit and this is your second digit. What are the digits? It can be 0, it can be 1, it can be 2, it can be 3, 4, 5, 6, 7, 8, and 9. So in total, you have 10 digits to work with. Now, part A of the question. How many pins are possible if you can repeat the digits? What's the meaning of that? It means that you can have the digit 0, 0, 0, 1, 0, 2, 0, 3, 0, 4, 0, 5, 0, 6, 0, 7, 0, 8, 0, 9. Can I switch the order? Yes. 1, 0, 2, 0, 3, 0, 4, 0, 5, 0, 6, 0, 7, 0, 8, 0, 9, 0. But if I want to have 1 and 1, yes, 1 and 2, 1 and 3, 1 and 4, 1 and 5. But how many I'm not gonna list these all, it takes forever. Instead, I'm gonna use the fundamental counting principle. It helps me to count this much more easier instead of listing these all. How many options do I have for the first digit? For the first digit, I can choose 0 or 1 or 2 or 3 or 4 or 5 or 6 or 7 or 8 or 9. So for the first digit, I have 10 choices, 10 options. Either of these numbers are fine. What about the second digit? Hey, I can repeat the digits. I am allowed to do that. So how many options do I have for the second digit? 10 again. Fundamental counting principle says, hey, the whole event can be done in 2 ways. The first one has 10 base. The second one has also 10 base. So in total, I have 10 times 10 or 100 ways of selecting the 2-digit PIN. However, the question might impose that you are not allowed to repeat any digits. What about this case? What about this scenario? What's the meaning of that? It means that, hey, there is no 0, 0 allowed. There is no 1, 1 allowed. 2, 2, nope. 3, 3, no, and so on. You can only have 1 and 0, 1 and 2, 1 and 3, 1 and 4, 1 and 5, 1 and 6, 1 and 7, 1 and 8, 1 and 9. You can have, for example, 0, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, 1, 7, 1, 8, 1, 9, 1. Then you have, for example, 2, 0, 2, 3, 2, 4, 2, 5, 2, 6, 2, 7, 2, 8, 2, 9. But again, I'm not going to list these all. There are a lot of digits. I don't like doing that. I learned something new in math. I'm going to use this method. How many options do I have for the first digit? For the first digit, you can select any of these digits, either 0 or 1 or 2 or 3 or 4 or 5 or 6, 7, 8 or 9. So for the first one, I have 10 options. For the second digit, however, I only have 9 options. If I select 1, I cannot select 1 again. If I select 0, I cannot select 0 again. If I select 2, I cannot select 2 again. So you have to reduce the number of choice to 9. So here you have 10 times 9 or 90 ways of selecting a pin if repetition is not allowed.